What are the requirements for a good control strategy? First, our control strategy must create a motion, which means that it should not be stuck in a loop. Why? This is because if we stuck in a loop, we will never get to the solution. We will just keep repeating states. And we said we don't want to repeat state. We can repeat rules, but we don't want to repeat states. Let's take this as an example. So if we are using the first match rule in the water jug problem, so we have the starting state 0, 0, and we want to reach a specific goal. So the first match rule will be this, because we have 0, 0, and x is less than 4. So we will fill the first jug and it will be 4. And the second one will have 0. So it will go to, again, is this the first match rule? No. This is the first match rule now, because y is less than 3. So y will be 3. So we will have 4, 3. Now it will go to the first match rule again. Is this rule matched? No, because x is not less than 4. X is 4 fully. The same thing for the 3. So we will go to the last rule that we have here, because we have x is more than 0. So is x more than 0? Yes, because x is 4. So this is now the first matched rule. It says that we have x minus d. We have to subtract x with a number. Let's say, for example, this number is 0.5. So we will have 3.5 and a 3. So this is our new state. Now we will go again to the first matched rule. So what's the first matched rule now? It's this rule. Because why? Because the x is less than 4. It is 3.5. So what we are doing here, we are doing a loop. We're just repeating a state. We will never get to the solution. So this is why this is not good. Now we will go to the control strategy. That the second thing is that the control strategy must be systematic. If we use a systematic method, we will 100% get to the solution. So some of the systematic methods are breadth first and depth first. Breadth first just mean going level by level. Depth first is going deep, and then if you don't find the solution, you can just go back. So using systematic method is good, but sometimes it is not effective in some problems. Like for example, the traveling salesman problem. Why is this? It is because it take too much memory, because there's too many paths. So we use something instead. We use something that's called an algorithm that's called a branch and bound algorithm.